When you search something on Google, the search engine works behind the scenes to find most relevant results from billions of the pages across the web. Sounds like a huge job, right? With billions of web pages and millions of queries each day, Google has to rely on some pretty advanced technique to get the results to you. Now there are multiple ways Google understand and rank these pages, but today we are going to focus on just one, and it's called TF-IDF, which stands for Term Frequency Inverse Document Frequency. I know that sounds complex, but don't worry, we'll break it down. Well, in simple terms, TF-IDF is used to figure out how important a word is to a document in a collection. By understanding which words really matter, search engine like Google can show you more accurate results. And while TF-IDF is just one of the many techniques Google uses, it's a great starting point for getting know how this system works. Ready to dive in? Alright, you might be wondering why TF-IDF is worth sticking around for. By the end of this video, you will know exactly why a rare word across a large collection of documents but frequent in one specific documents get more weight in TF-IDF. And that's one of the key ways search engine decide which pages are relevant. We are also going to dive into the formula behind TF-IDF, and don't worry, we'll break it down step by step and you'll see how it's actually computed. But that's not all. We'll also talk about some of the limitations of TF-IDF and why it's just the beginning of how Google rank pages. So stick with me, and by the end of this video you will have a solid understanding of how this technique really works. Now let's break down the first part of TF-IDF, term frequency. Sounds complicated, but it's really just a measure of how often a word appears in a document compared to the total number of words in a document. So the formula for term frequency is simple. TF equals number of times a word appear in the document divided by total number of words in a document. Let's look at an example to make it clear. Sentence 1, the dog chased the cat. Sentence 2, the cat ran away. Now we will calculate term frequency for two words, one from each sentence, dog and cat. Term frequency for dog in sentence 1. So the dog appears once and the total number of words in sentence 1 is 5. So term frequency is 1 by 5, that is zero point 0.2. And term frequency for cat in sentence 2. Cat also appears once. The total number of words in sentence 2 is 4. Therefore the term frequency is 1 by 4, which is 0.25. So as you can see, the term frequency value always lies between 0 and 1. So we can think of it like a probability. The closer to 1, the more likely you are to find that word in a document. Awesome. So this gives us a nice starting point to measure word importance. But we really need the IDF part to fully understand the big picture. Ready for that? The formula for inverse document frequency is also very simple. It's log of total number of documents we are looking at divided by how many of the documents contains that specific word. Now this formula helps us understand how rare a word is across a collection. Now let's look at two example sentences to calculate IDF of two words, one from each sentence. Sentence 1, the dog chased the cat. Sentence 2, dog is loyal animal. So assuming we have 5 documents in a collection, the word dog appears in 2 out of 5 documents. So the IDF is log of 5 by 2. That is log of number of documents divided by number of documents that contains the term dog, which is equals to approximately equals to zero point 0.4. Now the IDF of the word loyal appears in 1 out of 5 documents. So the IDF is log of 5, which is approximately equals to zero point 0.7. So what does the low or a high value of IDF really tells us? Now, since denominator, the number of documents with the word, is always less than or equal to the numerator, the total number of documents. When denominator increases, the fraction decreases. Thus, the log of fraction also decreases. And remember, this log value is always greater than or equal to 0. So in simple terms, if a word is very common like the, it has a low IDF value, suggesting it does not add much unique value. On the other hand, a word like quokka, a specific type of lullaby that appears in travel blogs, will have a high IDF value, indicating it carries more significance in identifying unique documents. So understanding IDF helps us grasp how search engines prioritize unique and relevant words. Now that we understand both parts of TF and IDF, let's see how they work together to reveal the true importance of a word in a document. Let's dive into how we can evaluate the importance of words in a document using a bag of words model combined with TF-IDF. What is a bag of words? Think of it as a way to look at a document as just a collection of words without worrying about their order or grammar. This allows us to focus on which words are important. So imagine we have a document about pets and our bag of words model include the following words. And let's assume we have a sentence of 8 words and the dog appears twice. Therefore, term frequency is 2 by 8, which is 0.25. And let's just say we have total 200 documents and only 2 documents have word dog in it. Hence, the IDF is log of 200 by 2, which is 2. Therefore, TF-IDF is 0.25 times 2, that is 0.5. Similarly, we can fill other values. But for simplicity, we'll assume and fill some values. Now, what does these values means? For dog, TF-IDF score is 0.5. This means the word is common in our document, indicating it plays a significant role in this topic. For cat, the score is zero point 0.3. It's a relevant word, but it appears less frequent than dog, so it has a lower score. The word loyal has a score of zero point 0.8, which means this is a keyword that stands out. It might not be common in other documents, but it is crucial for understanding the message of this one. Friend, with a score of zero point 0.2. Well, it's present, but not significant enough to add much to the document score idea. The term pet has low TF-IDF score because it appears frequently throughout the entire document, which focus exclusively on pets. As a result, its presence does not significantly distinguish or add any unique value to any particular document. So why is this important? Well, the words like loyal gets high TF-IDF score because they are rare in the broader corpus but frequent in this specific document. This shows their importance and helps search engine understand the essence of the content. By using TF-IDF, we can identify which words are vital for understanding main ideas, allowing search engines to deliver more relevant results based on what users are searching for. Now that we have explored TF-IDF, let's talk about how it affects search engine ranking. Finding relevant content. Search engine uses TF-IDF to identify which documents are most relevant to your search. If a word has a high TF-IDF score in a document, it signals that this document is likely to contain valuable information related to your query. When you search for something, the engine looks at TF-IDF score across countless documents. Those with highest score for your search terms are ranked higher, ensuring you see most relevant content first. Search engine prioritize documents that uses unique words effectively. So if a document contains rare but important terms, it stands out, indicating it has much to offer. And by leveraging TF-IDF, search engine can deliver results that truly meet your needs. Now let's quickly go over a few limitations. Context ignorance, which means it does not grasp the context of words, which can lead to some misunderstandings. Synonym issues. It treats different form of words as separate, so it might miss related meanings. For example, run and running are counted differently, which isn't ideal. Sometimes a rare word can get high score, but that does not mean it's important in the context of the document. Neglecting word order. So it overlooks the order of words, which means it can miss out on phrases that conveys a specific meaning. And static nature. TF-IDF score are based on fixed set of documents. So as a new content comes out, the model needs to be updated to stay relevant. Hooray! We have explored TF-IDF and its role in search engine. If you enjoy this content, please subscribe for more insights. Like this video and hit the notification bell to stay updated. Thanks for watching and share your questions in the comment below.